Welcome to Daily Papers, the podcast where we break down fascinating new research into plain English. Today, we're looking at a paper that sounds like it's straight out of a sci-fi movie. It's about teaching an AI to get smarter by making it play a social deduction game against itself.
I'm intrigued already. The paper is called Vision Zero, Scalable VLM Self-Improvement via Strategic Gamified Self-Play. That's a mouthful, so let's unpack it. First up, VLM. What is that?
A VLM is a vision language model. It's a type of AI that can both see and talk. You can show it a picture and ask it questions about what's happening, and it will answer you in natural language. Think of things like GPT-4 when you upload an image.
Right, and these models are incredibly powerful, but they have a huge weakness, which is how they're trained. It's massively expensive.
Exactly. Traditionally, to teach an AI to understand images, you need to show it millions of examples that have been painstakingly labeled by humans. You need people to draw boxes around objects and write descriptions. This costs a fortune and takes thousands of hours.
And there's another problem, which the paper calls the knowledge ceiling. The AI can only ever be as smart as the data humans give it. It can't discover things beyond what we already know to teach it.
This is where Vision Zero comes in. The researchers asked, what if we could get the AI to teach itself? What if it could generate its own training data, endlessly, and for free, pushing beyond that human knowledge ceiling?
And their answer was to make the AI play a game. This isn't a new idea in itself, right? I'm thinking of AlphaGo, the AI that mastered the game of Go.
You've got it. AlphaGo didn't just study games played by human masters. It got so good by playing against itself millions and millions of times. It discovered strategies that no human had ever thought of. This method is called self-play.
So what game did the researchers invent for these vision language models? It can't be chess or Go because those don't involve images and language.
They created a visual version of the party game Who is the Spy? You might know it as Mafia or Werewolf. It's a game of deception and deduction.
Okay, this sounds fun. How does an AI version of Who is the Spy work?
Imagine a group of AI players. All but one are civilians, and they all get to see the exact same image. For example, a picture of a red cube next to a blue cylinder.
And the last player?
The last player is the spy. The spy gets a slightly different image. In their picture, maybe the cube is green, or it's a sphere instead of a cube. The change is subtle.
I see where this is going. The civilians have to figure out who is the spy, and the spy has to blend in and not get caught.
Precisely. The game happens in rounds. In each round, every AI player has to give a one-sentence clue describing their picture. A civilian wants to give an accurate, specific clue to prove they're looking at the normal picture.
But the spy has to be sneaky. If they say, I see a green cube, when everyone else sees a red one, they'll be found out immediately.
Right, so the spy has to be strategic. It might look at its image and decide to describe something that is the same, like the cylinder is blue. Or it could give a vague clue, like there are geometric shapes on the table. It has to reason about what the others are likely seeing and craft a message to mislead them.
And after a few rounds of these clues, the civilians vote on who they think the spy is. This is brilliant because to win this game, the AI has to develop some really advanced skills.
That's the core insight of the paper. This isn't just a game, it's a perfect training environment. To be a good civilian, the AI needs to master visual comprehension, looking closely at an image and describing it accurately. It also needs to use logic to compare its image with the clues from other players.
And to be a good spy, it needs a kind of theory of mind. It has to infer what the others are seeing and then communicate strategically to deceive them. That's a huge leap in reasoning ability.
And the most incredible part is that the AI is generating its own curriculum. Every game it plays, the clues, the votes, the outcomes, all of that becomes new training data to make it better for the next game. All the researchers have to do is provide pairs of slightly different images, which can be generated automatically. No more expensive human labeling.
So just letting the AI play this game is enough, or is there a catch? I can imagine they might just get stuck, with one side always winning easily.
That's a great point, and the researchers thought of that. A simple self-play setup can plateau. If the spies are too easy to catch, they never learn to be sneaky. If the civilians can never find the spy, they don't learn to be better detectives.
So, how do you keep the difficulty just right?
They developed a clever technique they call iterative self-play policy optimization. Basically, they alternate the training focus. If the civilians are winning too easily, the system shifts focus to training the clue-giving part of the model, making the spies better and the game harder.
And if the spies are winning too often,
The system shifts to training the decision-making part, making the civilians better detectives at analyzing the clues. This back-and-forth process ensures the models are always challenged and constantly improving in a sustainable way.
so the big question is, did it actually work?
It worked incredibly well. They took a standard VLM, trained it using the Vision Zero framework, and the model's performance skyrocketed, not just at playing the game, but on a whole range of other, unrelated tasks.
Wow, so skills learned in the game actually transferred.
Yes, that's the key result. The model got significantly better at general reasoning, at understanding charts and documents, and at other complex visual question answering tasks. And get this, it actually outperformed other models that were trained on expensive human-created datasets specifically designed for those tasks.
That's amazing. So, by learning to be a detective or a spy, the AI developed more general, robust reasoning skills?
Exactly. It learned how to reason strategically, not just how to match patterns.
So, to wrap it all up, the Vision Zero paper presents a groundbreaking method. By having AI play a strategic visual game of who is the spy against itself, it can effectively teach itself, becoming more capable without needing expensive human-labeled data.
It's a huge step towards more scalable and affordable AI development. Instead of just feeding AI data from a textbook, we're building a virtual world where it can learn through experience, strategy, and interaction.
Really creative and powerful idea.
That's all the time we have for today. Thanks for tuning in to Daily Capers.